Hello, and welcome to Compadre Learn. In this brief tutorial video, we'll cover the R exercises associated with the lesson, Other Key Life History Traits from MPMs. Let's begin. We've learned that matrix population models are used to calculate population growth rate and stable stage distributions, but they can also be used to calculate many other important life history metrics, such as residence time of individuals in life stages and transitions, mean life expectancy, and generation time. In this tutorial, we'll cover 5 learning objectives. First, we'll examine population dynamics using the PopBio package. Then, we'll calculate residence time of individuals in life stages and transitions. Then, we'll calculate mean life expectancy and generation time. And finally, we'll use user-defined functions to calculate life history traits. For this tutorial, we'll be using R and RStudio, which can be downloaded at the links on your screen. If you're unfamiliar with this software, please visit the websites listed and familiarize yourself before continuing. We'll also be using the R packages mass and popbio, and you'll be prompted to load these during the lesson. You can download the R code used in this video as an R file or a PDF directly from the web page. You can also follow along with the lesson in the web page itself. Objective 1. Examine population dynamics using popbio. Let's start by loading the required packages. For this video, we'll be using the R file provided on the tutorial webpage. The next thing we're going to do is define a function called lifetime reproductive events, which we'll use later on in the lesson. This function will give us the probability of survival to first reproductive events, age at first reproduction, the mean life expectancy conditional on entering the life cycle in the first reproductive stage, and life expectancy from mean maturity. Since the function is quite long and complicated, please copy and paste from the PDF or the web page if you're not using the provided R file. At this point, we can either choose to use a matrix from Compadre or Comadre or create our own matrix model. Here, we'll create a matrix where individuals can grow, shrink, and stay the same size, individuals can reproduce sexually, and the population has a seed bank as its first stage. We'll start by creating the U matrix. The U matrix contains the survival-dependent processes and transitions. We'll check the stage-specific survival rates, which cannot be greater than 1, by summing the columns in the U matrix. If you find a value greater than 1, that indicates a typo or incorrect value in a survival matrix. Since there isn't a value greater than 1, we'll move on to create the F matrix. The F matrix contains sexual reproduction rates. Remember, you should only apply F matrix values to those stages or ages that can reproduce. Once we've created our U and F matrices, we will sum them together into a full, or A matrix. This A matrix would also include clonal reproduction if applicable to this species. You should now be able to see the matrices we created, as well as the function we created earlier, in the top right-hand corner of your screen. You can also view the matrices we just created by typing the name we gave them into the console window on the bottom left. Now that our matrix model is complete, let's start calculating some life history traits using the matrix model. First, we'll take a quick look at the overall population dynamics based on the matrix using the eigenanalysis function from the PopBio package. Since we're interested in the overall population dynamics, it's important that we use the eigenanalysis function on the A matrix. Once we run the eigenanalysis, we can then look at lambda 1, or the long-term population growth rate given by the dominant eigenvalue, and we can look at the proportional stable stage distribution and reproductive value given by the left and right eigenvectors respectively. The PopBio package contains many other useful functions for working with matrices, so we encourage you to read more about it after the lesson. Objective 2. Calculate residence time of individuals in life stages and transitions. Now, let's calculate the fundamental matrix, which we'll call N. This gives us the residence time of individuals in each of the stages and transitions, and we can view this matrix by typing N in the console window in the bottom left. Objective 3. Calculate mean life expectancy. We can sum all of the columns using the column sums function in R. Summing each column in the N matrix gives the mean life expectancy, conditional on entering the life cycle in each of the stages in our matrix model. Objective 4. Calculate generation time. Generation time is calculated using the net reproductive rate and lambda. To get the net reproductive rate, we will first multiply our fecundity matrix by the fundamental matrix N, which we calculated earlier. We'll call this new matrix R. Then we'll use the lambda function on the R matrix we just created. This gives us the net reproductive rate. You can view the R matrix and the net reproductive rate by typing their names in the console window in the bottom left. Next, we'll use the lambda function to calculate the reproductive rate of the A matrix, and we'll call this lambda. Finally, we'll calculate generation time by dividing the log of our net reproductive rate by the log of lambda for the A matrix. Like with the other values and matrices we've created in this lesson, we can view generation time by typing the name that we gave the value in the console window in the bottom left. Objective 5. Use user-defined functions to calculate life history traits. The final step in this tutorial video will be using the function we defined earlier, which we called lifetime reproductive events, to calculate some life history traits. Since we wrote in the equations that we want to use and the outputs that we want when we created the function, all we need to do at this point is set which data we want to use and then run the function. In this example, we'll use the U and F matrices we created earlier, which are the survival and fecundity matrices respectively. But you can also use U and F matrices from the Compadre or Comadre databases. We'll also specify the option start life equals 2, because in the matrix model that we created for this example, the first stage is for a seed bank, and typically in plant demographics, life starts after germination. For an animal matrix model, you would select start life equals 1. Now let's run our function. Here, the 4 output values correspond to the outputs we defined when we created the function. Prep is the probability of survival to first reproductive event. LA is the age at first reproduction. Mean rep life expectancy is the mean life expectancy conditional on entering the life cycle in the first reproductive stage. And remaining mature life expectancy is the life expectancy from mean maturity. For more information on these values, we encourage you to check out the book Matrix Population Models by Hal Caswell. This concludes our tutorial video. To find more helpful tutorials like this one, please visit compadre-db.org/learn.